In this video, I will demonstrate the use of any output pin to control a servo. And we'll also connect multiple servos. We're going to use the same counter like we did before to create the PWM. What we're going to do is, instead of outputting it to the OC1A pin, we will be outputting the PWM on any of the pins that we desire. And we're going to create our own PWM using the timer. So as we know, the timer counts up, and we're going to have it count up from 0 to the same number we had before, 19,999. And we're going to, instead of using the COM1A1 and COM1A0, which controls the OC1A pin, we're just going to output it using any of the pins. This will be our period, and this will be our next period from 0 onward. We'll still use the ICR to represent this number. And the problem that we're faced with is, how do we get this to start out at 5 volts for any pin and then go down to 0 volts for this period? Just like in the previous timer videos, we'll be using the TCINT or TCNT1 register, and this is going to equal the 16-bit count number. This is the thing that will be counting from 0 to 19,999. The ICR is only what contains this number to define the top. So what we're going to do is we're going to set this pin high initially, and then when TCNT gets to, say, 2000, let's pretend this is at the point 2000, then the pin can go low and be 0 volts, and then it can start all over again. From 0 to 2000, the pin will be high, and from 2000 on to the end of the period, which is 19,999, the pin will be low. To make all of this really easy for us, and also to make the program more compact, we're going to make it so the timer uses an interrupt to tell us when the timer has gotten up to its maximum value. And at that point, we'll raise all of the pins high. If we're going to use multiple servos, we can do this to all of the pins on that port, and we can just set them all to high, or whatever pins that you use. So to explain the process a little bit, when it gets to the interrupt, which is at the top, or this particular pin, let's say we're using pin B0, or port B and pin 0. So pin B0, it'll start out at a high point, and then we'll have an if statement. If the TCNT is greater than 2000, then we'll say the pin should be low. So it'll be low all the way to the end of the period, and then when the interrupt hits again, it'll go back up to a high point, and then the if statement will happen all over again, go to 2000, and then go back down to 0. And the number, the 2000, can be another variable. Like we could call it servo 1, for instance. As we program, you're going to get an introduction to also what is called state machines. And a state machine is where you're sharing a process throughout the execution of the program inside of the microcontroller. You can have a process, and then you can have another process that happens, and you can have another process that happens. And the process continually gets shared time-wise inside of the microcontroller. So you can have many functions happen and have these processes happen, and they can also be priority format. So maybe this one happens more often, or it will get called in emergency situations, and then this one will get called second, and then third, and maybe it only sticks here for a little bit and then it goes back to this point. This type of situation is actually pretty important in controlling servos, because you will want to try to share the time when you're with microcontrollers. You want to share the time of the microcontroller with the servo and with other processes. We're first going to start with a simple single pin, and we'll output a PWM so we can control one servo. Let's go ahead and go to our programming environment and see how that works. We'll start with our usual skeleton code. We have the standard io.h file to provide the standard functions for the AVR. And we have the main function, and our never-ending loop. Since we're using interrupts, we might as well start by setting up the interrupts. Include the interrupts.h file. And we're going to need to set the global interrupts. And now we need to set up the interrupt service routine, ISR, and we'll have our vector inside here. We're going to use timer 1 and compare A, and that's the vector. And we'll put whatever code we need inside this area here. We know that we need to set our pin high inside this interrupt service routine, so we can go ahead and do that, but we really don't know what pin we're going to be using. So I'm going to just go ahead and say we'll use port B and pin 0. First I want to set those for output. So DDRB, this is for port B, and this is the data direction register. And we're going to go ahead and make that equal to 0xFF. And this is setting all of them to output from pin 0 all the way to pin 7. So here we can go ahead and set the port B to output. And we could do just that, just the first pin 0, but I'm just going to go ahead and do all of them, because later on we'll use more than one pin to control servos. So when the timer gets to the top, it's going to bring the output level to 5 volts for port B, all of port B. Now let's set up our timer. We'll start off by setting the timer to use fast PWM, and just like our previous PWM timer control, we'll use the fast PWM and we'll use the ICR 1 to be the top, creating the period. The waveform generation mode bits are 11, 12, and 13 for the fast PWM, and using ICR as the top. We'll need to use both registers, the control registers, TCCR 1A and 1B. And this is where the waveform generation modes are. Waveform generation mode 11 is in TCCR 1A. We'll use the shift operator to get 1 in that bit. And 12 and 13 is in 1B. We also know that we don't need any prescaling, so we're going to use the CS10 bit. And to enable the interrupts, we're going to have to use the timer mask. The timer interrupt mask is located in this register. And I'm adding a 1 on the end of this because for the Atmega32 you need the 1, and you can look in the data sheet whether you need to include a 1 or not. In the Atmega32 you only need to have the TIMSK without the 1. So I'm going to put the 1 in. And if you remember back from previous videos, we did the timer interrupt. We're using the output compare interrupt enable 1A bit. Put a semicolon. And now we can define our top, which is the ICR 1, and that's going to equal 19,999. So now we've set up our clock using the waveform generation mode of fast PWM. We're getting a period of 20 milliseconds. We're using no prescaling, and we're setting up our interrupt. So when this gets to the top, we're going to get into this point and we're going to set the port B to a high level. Now we need to figure out how to set the port B to a low level at the appropriate time. Okay, now we need to set the port B, the particular pin we're using, to a low value. So how would we do that? We could do this. If TCNT1 is, let's say, equal to 2000, then we would set that pin low. We would do this. Port B at equals the not 1 shifting pin B0. And this would be our output pin, the pin B0. And we're going to be setting that one to low once we get up to 2000. But the possibility of actually meeting 2000 at this point would be slim because we're doing a lot of things with this program. So we may actually miss the 2000th count. So what we need to do is we may need to say if it is greater than or equal to 2000, and then it sets it to 0. But we'll also have a problem with this too, because we don't want it to continually set this to 0 from 2000 all the way to 19,999. That's a lot of taxing the microcontroller, and we really don't want to do that. So what we'll do is we'll only perform this if that particular pin is set or is 1. If it's already 0, it doesn't really need to do this. It doesn't really need to do this entire line at all, because when we set it, it's always going to be 0 until we bring it back up to a high level. So let's go ahead and say if the bit is set, and this is a function that we can use to determine whether a particular bit is set or not. So I can put port B, that's the first argument, and the second argument is the actual pin B0. So if it's set, then we can go ahead, if it's set and it's greater than 2000, then we can go ahead and bring it low. Otherwise, it won't do this at all. So this at least takes into account that whether the pin is set or not. And this program will probably work. But we're also not really being very efficient with the microcontroller. I only want to check these pins and check for the length of the pulse only from around 800 to 2200. I don't really need to do any of these checks if it's outside of that count. So let's go ahead and make another condition. If TCNT 1 is greater than 800, or actually, and TCNT 1 is less than, let's say, 2400. And then we'll perform the conditions. And we can do all of the conditions that we need in here. Like if we're going to do any of the pins, we can set it within this particular condition. And any other part of the program would be happening if TCNT 1 is less than 800. I'm going to say greater than or equal to here, and less than or equal to. So if it's less than 800, or if TCNT 1 is greater than 2400, then we can perform any other task that we need to give to the microcontroller. So, in other words, this is actually our state machine. We will take care of all of the functions for the servos here, and we'll take care of any other functions that would be here. We can probably fit maybe a few more lines of code for other functions within this area, but if you start to see your servos degrade in quality, then it would probably be better if you took all of that code and put it into this area here. So what this code is doing is it's setting up, it's bringing our direction for port B to output. We're setting up our timer and also creating an interrupt for the timer. We're setting the top values so we can get 20 milliseconds. And within our never-ending loop, we have a section of our never-ending loop that is dedicated to servos and the control of the servos. And we have another part that is dedicated to other functions, and maybe even changing servo numbers. That would also be in this location. So when it gets to the while loop, it's going to check first if the timer is within the span of time that would need to take care of the pulse portion of the PWM. And then if it is within that portion, then it will check to see if that particular pin needs to be changed or not. And then it'll come out of there and then do any other tasks that need to be done. Let's go ahead and try this and see if it works. I'm going to go to Tools, Make All, and see if I have any errors. Looks like I don't have any errors. Let's see, nope, no errors. And now I'm going to go to program the microcontroller and see if it works. Okay, the microcontroller is programmed, but you'll notice that I don't have a servo connected to the pin number 1 or pin 0 on port B. But I do have a probe connected to it. And I'm going to show you what it looks like on the oscilloscope, what the PWM appears. And you'll see the PWM, you'll see the square wave, and you'll also see the period that we've created. So here's what our pin B0 on port B looks like. I have this at 5.0 milliseconds for each division. You'll notice that if each division is 5 milliseconds, this is 5, 10, 15, 20. So we have 20 milliseconds between this point and this point. This is one period. So we've successfully created a 20 millisecond period. And you'll also notice that there's a little square wave here. And this represents our 2000 or our 2 millisecond. I'm going to increase the size of that. And for each division, now we have 2.5 milliseconds. You can see it's below this line, so we're somewhat accurate on showing us the 2000 or the 2 milliseconds. Increase it a little bit. So now I have it at 1 milliseconds division, and this shows 1 millisecond and 2 milliseconds, and it's pretty good. You can see where it lies. And in some cases I will want to go even larger, and so we can see both sides of it. And you'll start to see a little bit of wiggling here. And if you get too much of that, then you're going to start to see the servo give a little bit of a problem, and it'll continually start to jitter a little bit. We're not going to get any jittering on this. This is relatively good, so we can go ahead and hook up the servo and see how it works. So I'm going to take this servo, the little hobby servo, and I'm going to connect the positive, the red wire to the positive and the black wire to negative. And then I'll put the signal pin on pin B0. And you'll notice that we have our hobby servo. It is stationary at this position. If I take it out and I move it to another position, you'll notice that it goes back to that position when it's, there you go. You'll also hear a little bit of ticking inside, and that's what you saw on the oscilloscope, that little tiny bit of variation. So now let's hook up two servos. We'll use both pins B0 and B1 and see if we can get different positions on the servos using just standard pins, available pins. Okay, so we're back in the program. All we need to do to make this use two pins, since we're already making the data direction for the entire pin set of port B, and we're bringing that high when we have an interrupt, we can just go ahead and go right here and add another line. And let's make this one at 900. Let's go all the way around to the other side. 1000. So now we're going to have the we have to select a pin, and that's going to be B1. We'll do that here also. So we've set B1 to go low if it is greater than or equal to 1000. Once it's gone low, it doesn't need to do this anymore because the bit will already be low and it won't equal the bit set. Let's go ahead and try this and see if it runs or makes no errors, and let's go ahead and program the microcontroller and see if we get two different positions using two servos. Before we hook up another servo, let's go ahead and check to see if we have the correct PWM coming out of these two pins. So we'll go back to pin 1 and check the output on the oscilloscope. I'm going to go ahead and bring it back down to about 1 millisecond per division. And this is pin number 0 on port B, and we're getting 2 milliseconds. And we set the other one to 1 millisecond. So let's try pin number 1. And sure enough, we have the pulse going only 1 millisecond, the first division. So let's try putting both servos, one on each pin. We'll attach the first servo. You'll notice that it's gotten to that position. If I go to the next one, it'll go to the next position. So let me just go ahead and plug in the next one. Okay, so now we have both servos connected to the microcontroller, and they're both at the positions they were commanded to be. Let's add more servos to other pins. To make this a little bit more clear, I'm going to go ahead and take this out because it's just a little bit, makes the program look a little bit too long. And I'm just going to take these and I'm going to put outputs to 0, 1, 2, and 3, which are 4 pins. And I'm also going to set output to, let's say, port A. 4 pins of port A. So all I have to do here is change these to A. So we're outputting to pins, or to port A, pins 0 through 3. This has to change as well. And I also have to provide data direction output for A as well. And down here I need to set port A to be high whenever we start the new period. Let's vary these numbers a little bit. I'll make this one 1500, so it's kind of in the middle. And I'll make this one 800. I'll make this one 2300. Go a little high. I'll do this just an arbitrary number here. 1800. And we'll do 1850. Let's see if I have any errors. No errors. So let's go ahead and program and see what happens. Now the microcontroller is programmed. I only have 3 servos, so I will only be able to show 3 servos at a time on the pins. But I'm going to take one servo and go from pin to pin, and you'll see how the servo moves from one pin to another. So you can see when I plugged in all of the servos, they went to their positions, with respect to the pin that they're plugged into. I'm going to take out all of the servos except for one, and I'm going to go from pin to pin, and you'll see what we've assigned. I'm going to see if I can do this so you can see all of it in focus. Okay, so I'm going to take this servo and go from pin 0 to pin 1. Okay, and then to pin 2, and to pin 3. You can see that it's still relatively low jitter, or almost no jitter at all. And let's go to pin 0 on A, pin 1, pin 2, and pin 3. The pin 2 and pin 3 we had 1800 and 1850, so you're not going to see much of a difference there. So we have successfully implemented the multiple pins output for servos. I'm going to show you by taking out the state machine, the condition that we have, and allow it to do the conditions of each pin throughout the 20 milliseconds, and you'll see how that taxes the microcontroller. Okay, just as an aside, I want to show you if we took out this condition, this condition only allowing these sub-conditions to happen between the 2 millisecond range, or the 2.5 millisecond range, how much this actually does tax the microcontroller, and how the servos will respond to that type of processing. I also want to show you that these 2000s, or the 1000 or 1500, these can easily become variables. I can make this, let's say, servo 1 variable. I'll call this one servo 1, and I'll make this one equal to 2000. And we can easily just take the servo 1 and replace it with in this location. So now you can see that just by putting servo 1 here, we can almost do anything with this particular variable. We can change it through time. We can make it respond to a button click. We can make it equal to some variation of potentiometer signal coming from the ADC. and also an accelerometer or whatever we want to do with this. We can have the servo respond to almost anything. So keep that in mind when you're programming it. I'm going to put this back to the 2000 that we had before, and we're going to see how the servo responds to this, what I would say is poorly written programming, not using a condition surrounding these conditions. So let's go ahead and do a make and program. No errors. Let's go ahead and program it. Removing the condition, you can see that it does quite a bit of, there's a lot more noise in the servo. There's a lot more jitter. Let's see if I go from, let's see what happens with other pins. This one's quite violent. You can see that it's moving quite a bit. Same thing here. That one was really bad. So you can see by just a small change in programming, you can affect the performance of a servo. You can make it jitter, you can make it noisier, and you always want to try to find the most efficient way of programming and using conditions in a good manner to be able to control the servo or whatever you're controlling in a way that it's not going to take too many resources from the microcontroller. So in this tutorial you have seen how to control multiple servos from the microcontroller, and you can use any available pin. I've done tests prior to this just to prepare for this particular video. I went ahead and did all of the pins that I had available except for port C, because port C is generally used for JTAG interfacing. So I did all of the pins for port A, port B, and port D, and it worked flawlessly, and there was extremely little jitter, if any jitter at all, doing it with the method that I showed you. Thank you for watching. If you are following along with these experiments or producing successful projects on your own, helped by these tutorials, please let me know using the Contact Us page on the newbiehack.com website. I would like to feature these on the website to benefit and motivate others to join this creative field. Thank you.